Alright, so yesterday we talked about finding a tangent line, an equation that represents the slope of a tangent line. And in order to do that, we use the difference quotient, which is really the slope of a secant line that connects through the graph twice. And we use the limit process to get those points to kind of get closer and closer together so that essentially they're touching each other. Because the h, the distance between the 2 points, is approaching 0. So using this function here, instead of x, we're plugging in that x plus h because the difference quotient says f of x plus h. So we would have 1 over x plus h and then plus 4. And then it says minus f of x, so I need to subtract that. And then that's all over h, which I saw a lot of you had this setup stuff. So this would be that initial part where you're setting the problem up. Where do you go from here, Brandon?
You multiply the first term by x plus 4, and the second term by x plus h plus 4, so you can have a common denominator.
Right, so last week we talked about many methods of altering the appearance of a function. So the easiest way is to just directly substitute, but that doesn't work for, 90% of the problems. So then you can factor, you can rationalize, which means multiply by the conjugate. We can use common denominators, so those would be 4 different options. The last option would be the technology. Let's see. So he said use the common denominator. Both of these denominators are different. A common denominator consists of all of the different factors being multiplied together. So my 2 denominators get multiplied together, x plus h plus 4 times x plus 4, because they are 2 separate factors, 2 separate denominators. Even though they're this similar, one is different because it has a plus h. So that means the one on the left needs the x plus 4. The one on the right needs the x plus h plus the 4. And then of course it's all divided by h. So I have x plus 4. And then here's where you have to be careful. This minus sign goes with the 1. So I'm subtracting that second fraction, which means we have a negative x, a negative h, and a negative 4. So that negative sign is we get to be careful with the negative sign. The minus 1 distributes and it makes it a negative 1 that you take through. So what happens in the numerator when you're trying to combine some like terms? Yeah, so the x's cancel, the 4's cancel, and you're just left with that negative h. On the bottom, I'm going to leave this as x plus h plus 4, and then x plus 4. When you're dividing by h, really that means you're multiplying by 1 over h, the reciprocal. So combine the numerators together by using common denominators. Get all those pieces to cancel, and then what you have left also cancels once you multiply by that 1 over h. So we have those terms canceling, and we just have a negative 1 on the top, and then we have x plus h plus 4 and x plus 4. So this part here that's remaining, that's the difference quotient part. That's the secant line part. The secant line is the slope of 2 points, and that's what this is here. But once we use the limit process, we can find then the slope of the tangent line by taking that 0 and plugging it in for h. So what you have remaining is x plus 4 times x plus 4, which if you have the same factor written twice, we say that it's x plus 4 quantity squared. On the top, there's still a negative 1. So this would be the slope of the tangent line at any point on the graph. That's the equation that represents the slope at any point on the graph. They specifically gave us 2 values of 0, 1/4, and negative 2.5. Eris, what do you do then to find the specific slope at the point 0 and 1/4? What letters do the order pair represent?
X and Y.
X and Y. So what are you plugging in for X?
X is 0.
X is 0. So you're just going to plug a 0 in for X. So I'm finding the slope at the point 0, 1/4, which means I have 0 plus 4 squared, which would be 16. And then the second point was 2.5. So now you're plugging a 2 in. 2 plus 4 is 6, and 6, is it a -2?
Yeah.
Oh, thanks. -2.5, so -2 plus 4 is 2. 2 squared is 4. Questions? Are there other questions from the homework you wanted to talk about? Bridget? Number 15? So that was the 4 over x function. And then this one was 2. So if we set this problem up very similarly, we would have 4, and then in place of x, x plus h. And then minus 4 over x. So again, f of x plus h minus f of x. And then everything's divided by h. Kate, what would the common denominator be for number 15?
X and then X plus H.
Yeah, so this one has an x. The first one has the x plus h. Even though they look similar, they're different factors. An x plus h is different than the x by itself. So the x goes with the first, that becomes a 4x. The x plus h goes with the next. Remember, it's a -4. So -4x minus 4h. And then that's still divided by h. So just like the last problem we did, those terms cancel. So 4x minus 4x goes away. We have a -4h on the top. And then we're dividing by h, which really means multiplying by 1 over h. So, Brandon, our h's cancel, leaving us with,
-4 over x.
yeah. And Brandon, when you plug a 0 in, what's the equation for the slope? -4 over
x squared.
x squared. So after you do all the simplifying, you finally have -4 over x times x plus h. So we're plugging the 0 in, and we end up with -4 over x squared. The actual slope at the point 2, 2 would be a -1, because you're plugging the 2 in for x squared. Other questions? So we're going to look at 2, maybe 3 final problems. Kind of wrap up the tangent line. And this is in your packet on page 23. Tomorrow and Monday, we'll just kind of review. A lot of my students, I think there's a push test tomorrow morning. Yeah, right? So I know there's students in my morning 2 classes taking the A-Push test, so tomorrow is just kind of a summary review day. Monday will be another summary review day, and then Tuesday we're taking a test. I'll get those tests that you took yesterday back to you tomorrow. Tests you took Tuesday back to you tomorrow. So example number 5, at the top it says the definition of, I should have the word A in there, the definition of a derivative, or of the derivative. It says to use the limit process to find the slope of the equation at x f of x, which is the directions of like those 5 problems that you were asked to do last night, the first 5. Except that the first 5 problems gave you a 0.22 or the 0.014, -2 and 1/2. They gave you a specific point. But in this case, we're just using any point because that's what the equation that we find really represents. So how would you use the limit process to find the slope? What does that mean, Brandon?
Plug it into the difference quotient.
Yeah, that's what it actually means. So use the limit process just applies the fact that we're taking the limit eventually but we're using the difference quotient. So anytime it says find the slope, the difference quotient really is the slope. They mean the same thing. The difference quotient is actually y2 minus y1 over x2 minus x1, but it's just applying it to any point on the graph. So we have that f of x plus h minus f of x all over h. So every time we did the difference quotient, we were really finding the slope of 2 points on our function. So x squared means take the x plus h and square it, and then plus 1, because that's just part of that first initial function. Subtract f of x, so we're subtracting that function, and then you're dividing that by h. So Chelsea, if you FOIL distribute, what do you get?
X squared plus 2xh plus h squared minus x squared minus 1.
Yes? You and Sadie have the same goal. I think it's allergies and cold combined together.
And all the windows and everywhere.
Yes, yes, yes. So then the next part, you have all those things that cancel, wiping those pieces that are in common out of the problem, and then looking and making sure that the only things you have remaining in the problem have an h in common. If not, you missed a negative somewhere, you didn't FOIL correctly, multiply correctly, but whatever's left, you should be able to factor out an h. So that we can cancel the denominator, because that's what was keeping the problem undefined. And then plug the 0 in, and we end up just with the equation 2x. So that's the equation that represents the slope of the function at any point on the graph. So it isn't actually the slope, because I can't find the slope until I know what point that we're talking about on the graph, but it's the equation that represents the slope. So underneath, there's a little piece of information. It says, notice that we use the limit process, that's the limit as h approaches 0, to derive another function. And that was the function, that 2x. What does derive mean? So you derive something. And you make something smaller. You're kind of taking the original equation easier, but you're creating something from an existing equation, or an existing piece, whatever you have. So we have derived this new equation. We've created this new equation from our original equation. That new equation represents the slope and is called the derivative. So the word derivative is a huge calc concept that we are just like skimming the surface, literally. But it's called a derivative because you created this new equation. You derived it from an existing equation. Now this is actually something that we've kind of done before, because we've created equations based off of functions. The one equation we created used this notation. What was that notation called? Kate? Yeah, inverse notation. So we found the inverse of a function before by switching x and y and coming up with a new equation that was related to the first. So that was a process to come up with an equation that was called an inverse. Our equations are called derivatives because we're using this process of limits to find, again, a new equation that we derived from the first, but we used a different process because we used the difference quotient. So it's called the derivative. Of course, an inverse has a special notation, so a derivative has a special notation as well. And this little symbol there is kind of like having a little comma. That's called a prime symbol. So it's related to the original equation because it has the f in front of it, and it's read f prime of x. So math steals a lot of grammatical symbols, and we use like the exclamation point to represent factorial. We use a colon to represent odds. We use a comma, or an apostrophe, not a comma, an apostrophe to represent a derivative. So f prime of x is called the derivative. The derivative is the same thing as the slope of the tangent line. It's just a different way of naming it. So we're really focusing on the function 2x, that equation that you have left. So a derivative and the slope of a tangent line are exactly the same. Just like when we learned functions, y and f of x are exactly the same. F of x is showing we have a function, y is still a function, they still represent the same thing. The slope of the tangent line is the derivative is the slope of the tangent line. They're kind of interchangeable. So the derivative is more like just looking at the equation, the slope of the tangent line is kind of attaching it to the graphical curve. Questions? So the problem at the bottom is a big one, but it kind of connects some things that we've been talking about all year, which is why it's like the last thing that we're learning that we knew this year. So it wants us to find the derivative, f prime of x, of the given function. And we're going to stop there and then we'll answer the rest of it. But let's just work on this derivative process. So if we want to find the derivative, Chelsea, what are you really doing to find the derivative?
Finding the slope of it.
Right, so the derivative is the same thing as the slope of the tangent line, which really means we're taking the limit as h approaches 0 of f of x plus h minus f of x all over h. So each one of those things mean the same thing. The difference quotient is the slope of the tangent line, is the derivative. All the same thing. Just depends where you're learning at it in math and what you're applying it to. So we're taking x plus h, plugging it in with the 3 and squaring it, minus 2, and then that x plus h. And then you're subtracting the function, which I ran out of room. And then we're subtracting 3x squared minus 2x. And all of that's over h. How many buses are backing up to San Antonio out there? All of them, yes. See if you can try and FOIL, distribute, simplify that expression once we plug in the x plus h. So 3 times x plus h squared minus 2 times x plus h minus the function. Brandon.
I want to say, for the one
Do you have it?
Yeah, I have it.
Okay, what do you have, Brandon?
It is 3x squared plus 6hx, or 6xh,
Okay, you're good.
plus 3h squared minus 2x minus 2h minus 3x squared plus 2x.
Nice. There's a lot of stuff happening there. So that's foiling x plus h squared, x squared plus 2xh, or hx plus h squared, and then multiplying it by 3. So FOIL it, multiply it by 3. Distribute the negative 2, distribute the negative. And we have this huge long problem. Libby, what reduces cancels for us?
The 3x squared. And then the 2x. That's it.
And then everything that you have left has
The h.
the h in common. So we have an h with the 6x, an h with the 3, and then that negative 2. So we can wipe out those h's. Our goal was to find the derivative, the slope of the tangent line, which is this new equation that we, bless you, created from the first. So now we've derived this new equation. And Kate, what is that new equation once you plug the 0 in? Yeah, 6x minus 2. Don't factor anything out. Keep it as a 6x minus 2. That is our derivative. So the derivative, the slope of the tangent line, is 6x minus 2. Question. So essentially, it's the same thing we did last time. Just calling it a derivative.
Why is it called something different? Like, why is it different? Like, what makes it different?
we literally derived it from the original equation. So, that's it. And we're math people. Not English. The tangent line is more graphical, so the tangent line on the graph connects to the curve. The derivative is more like equation based. So now we're going to answer the second question because it kind of applies both of them together. Brandon,
Whenever it says that if the tangent line is horizontal,
we're going to talk about that.
tangent line wouldn't have to be the vertex.
Can you just give me a second? Or 30. So the next question says, use the derivative, use this equation, to find any points on the graph where the tangent line is horizontal. So we have this equation, 3x squared minus 2x. What's the equation look like? So, Virginia, what's that equation look like? Not the new one, the original. Right, so the original one is a parabola. So we're going to take this parabola, and I don't need you to plug it in your calculator. I just need you to think of what it looks like. Virginia, why does the parabola open up and not down? Right, so we have a positive 3x squared. So what's a parabola that opens up? It has a y-intercept of 0 because there's not an extra plus c value in the back. But you don't even need to remember that. We're just going to go off with a nice little parabola. So we're going to use this parabola to find a point on the graph where the tangent line is horizontal. So now back to Brandon. It may have been a minute later and not 30 seconds. Brandon, what were you saying?
For if the tangent line is horizontal, for it to be a tangent line, it only has one point, which would be the vertex.
So if we're trying to find a horizontal line that connects with our graph, the only place that it's going to be horizontal is at the lowest point or the highest point. It doesn't have to be the lowest point. So we're going to draw just a little diagram. Again, it's not exact, but that would be the graph of my tangent line. Not quite, but you're on the right track. So if this is the tangent line, the slope of a horizontal line is 0. So the slope of a horizontal line is 0. So any horizontal line, no matter where it is always the slope of 0. How can you apply that slope to figure out this point? Because that's what our goal is. We want to know what's that x comma y. So how does the slope get applied to what we currently have so we can figure out the point where it's connecting with the tangent line?
You said 6x minus 2 equals 0.
Why do you set 6x minus 2 equal to 0?
Because before we would get this equation and then we would use that equation to find m, and since we already have m, we can use it to find x.
So the derivative really means the slope. The slope of a horizontal line is 0. So I can take the slope that we now know and set it equal to 6x minus 2 and solve for x. You could do that for any slope. So I could say find the point on the graph where the slope is 2. Find the point on the graph where the slope is 5. So yesterday we gave you a point and you found the slope. Today we're kind of flipping it and doing the opposite. We're finding that point on the graph. So Michael, if you solve for x, you get 1/3. So now we know that the point, the x value is at 1/3. How do you find y? Anytime you know x, how do you find y, Michael? Yeah, you plug it back in. So, taking the equation, the original equation, because we're trying to find the point on the original equation, where this line is horizontal. So we know it's 1/3. Doing a little bit of mental math here, 1/3 squared is 1/9. 1/9 times 3 is 1/3 minus 2/3. That's sloppy. Michael, what is 1/3 minus 2/3? Negative 1/3.
Yeah.
So now we have a way to find max and min values of graphs. Because you're going to find the max or the min of a horizontal tangent line. So any graph that has a curve, a max or a min, we can now find the derivative, which is really the slope of the tangent line, which if the slope is 0, because it's horizontal, I can now find the placement of x. Where before we had to use the calculator. Woohoo! Question. So your homework, yes, it's 33 to 37 odd and 55 on page 777. And then on 799, you have 5 other problems. They all pretty much are asking you to do the same thing. The phrasing of the question might be slightly different. Alex, you want to try number 37? Sure? Nick, you want to try 55? Sure. Is he going to remember?